My friends, we're going to derive this relation right here. The heat equals the change in enthalpy without using calculus. And to do that, we're going to start off with the first law of thermodynamics, which says that the change in internal energy equals the heat plus the work. And the work is going to be equal to the negative pressure times the change in volume. And now this is true. This equation is true for pressure volume work only, so no electrical or other types of work, and under constant pressure. If you want me to derive this equation, let me know in the comments. I'd be happy to do that. But otherwise, we're just going to substitute that into the first law right here. And we get this. And now we're going to solve for the heat. So we'll move this over to the other side, and we get the heat equals the change in internal energy plus the pressure times the volume. All right, cool beans. So we're going to move this up, and at this point, we're going to define a new state function, h. And h is enthalpy. H is a state function, and it's defined as the internal energy plus the pressure times the volume. And therefore, the change in enthalpy is equal to the change in internal energy plus the change in the pressure times the volume. Now, this is true. Uh, Enthalpy is a state function because all of these variables are state functions that they depend only on the initial and final state. And since our process is a constant pressure process, that was a tough one, we can pull it out of the change here. Well, look at this on the right-hand side. This is exactly the same as what we have on this right-hand side of the expression here. So the heat, the energy transferred as heat under constant pressure is equal to the change in enthalpy, and this is our derivation right here. I'm just going to give a few words to talk about the importance of this derivation. And h is a state function, which means that it only depends on the initial and final states. So we can do the change in h. And this is important because the heat is not a state function. Heat depends on its path. It's like friction. It depends on how we did it, just like work as well. But because this is equal to the state function here, this change in the state function, we can determine the heat transferred only based on the system's initial and final states only. Now, this is true for a process that has constant pressure, that has PV work only, and for a closed system. All right, y'all, hope you enjoyed it. Check out my many other videos on thermodynamics, also calculus and physics, and we go through many exam problems and other derivations in theory. See you in the next video. Thanks so much. Cheers.